Well, as we return back to our new normal schooling after hopefully what was a restful spring break, we kind of need to get back into things. So we're going to start with a little bit of a review from the previous week's information, and then we'll roll it into some new things. We'll have a Zoom meeting, of course, and we can discuss how the end of the year is going to look with the new um, grading rules that have been rolled out, so that'll be for another discussion. What I'm going to do here is answer the questions that relate to the two Google form questions that were asked last week. I believe they were called 2.1 and 2.3. And these are essentially going to be your attendance. It's going to be your proof that you are a part of the class, that you deserve a passing score when you when you select your grade. So with that, um, looking at 2.1, this involved the balloon lab. And if you didn't go through and do the balloon lab, you should have at least watched the video that I had made so you could see what the reactions are. But to go through the answers very quickly, we held the tape and the balloon together. The tape was off of a desk. That tape, if I combine the first two questions, and if you want, you can pause this video and find your answers. I do believe they would be saved uh, somewhere, but if not, you can reopen those. But basically, the first two questions involve tape and the balloon. We ripped the tape off of the desk. It's negative. I held it next to the balloon. It was repelled by the balloon, which means that those two things must have the same charge, which means that the balloon must have a negative charge. The third question says, what must the fur or the hair have? The balloon was charged up by the fur, so when the balloon becomes negative, it must have taken negatives from, or the electrons from something. That something is the fur, which means if the fur lost negatives, then it's going to be left with a positive overall net charge. The fourth question asks, where does the charge reside? As in, I took the fur, I took the hair, I rubbed it on the face of the balloon. That balloon's face seemed to hold the charge because when I would bring in my hand, it was the face that was attracted to my hand. When I brought in another negative item, it was the face that was repelled, not the whole balloon, just the face. So with that in mind, that's showing us that the charge stays stuck in one spot. In the last on the balloon, and the last question was, just from previous experience, would you say that the balloon is an insulator or a conductor? And hopefully you've done this before, where you recognize that the balloon, that rubber material, is an insulator. Maybe you were thinking of a heat insulator, which is why you have rubber handles on certain things that can get hot. Same thing. If it's typically if it's a heat conductor, it's going to be an electric conductor as well. If it is a heat insulator, it will also be an electric insulator. And that went really well with lesson 2.2 of the week last week, where we talked about conductors and insulators. The third, the 2.3 questions that we have go along with our PHET simulations. This one right here might be one of the worst simulations ever. It's so bad, it's good. Uh, it says, question number one, what is the charge method when John Travoltage rubs his foot across the carpet? Terrible sound effects. But what you have there is you have friction between the insulating rug and the insulating part of his shoe. Question number two says, proof of human conductance. Humans are a conductor. Well, I see that because my negatives are easily moved throughout the body. They don't just stay stuck on the foot, they move around. Now, obviously, this is just a simulation. Now, what happens when we bring our hand near the door? Yes, awesome sound effects. When he brings his hand near the door, we see the charges jump into the door. That's because the door represents the ground. The door handle is going to be a route to the earth, and what that's going to do is that's going to allow all those negatives that had built up inside John Travoltage, it allows it to flow into the ground where it can spread out more. And so we had discussed in 2.2, we had discussed the concept of the ground. The ground is just a really, 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 really big conductor, or a path to one. And so those negatives can now spread out into the ground. because one conductor touching another conductor, they share their charge, and all that charge gets shared into the big thing. When charge is shared between conductors, the bigger one gets the most. And if you have the Earth, which is infinitely bigger than us, it's going to take all the extra charge, leaving us neutral. That's question number 3. Question number 4, does the amount of charge matter? Well, if we take John Travolta's hand and put it back up there, and we really... Again, awesome sound effects, because ouch. What? Uh, does the amount of charge matter? Yeah, more charge means that we can jump through the air. Air is an insulator. We can jump through the air with a bigger gap. And so that's what we see when we look at that question, does the amount of charge matter? Basically, what we're looking at is you're looking at electric shock. And what is an electric shock? An electric shock is a lightning bolt. The lightning bolt can be really, really small and close and quick, and it can be bigger and bigger and bigger depending on how much charge is built up. If you build up a ton of charge up in the clouds, you can get an electric shock between the ground and the cloud, and that's called a lightning bolt. So we just have basically little teeny tiny lightning bolts going on when we have an electric shock. So the more charge built up, the more air insulator, the more it can jump through. When we look at our second one here, this involves a balloon in the sweater, and what we have is a charge method. I have two insulators rubbing past each other. I can see the negatives build up on the balloon. So the first question is, what charge method did we have? It's friction. If I let go of the balloon, it gets attracted right back. Opposites attract. That makes sense. Let it go again, it gets pulled right back in. So what happens to the negatives when I pull it over the wall? Well, I watch the negatives shift away and the positives don't move at all. So the negatives are the things that have the ability to move, and the positives do not. If I reset and I take the balloon over, I've got equal numbers of positives and negatives, which means that my little blue negatives in the wall have equal amounts of attraction and repulsion. So rub it on there, bring it over, I let it go, and now the balloon stays because these negatives are closer to the positives, strong attraction. Farther from the negatives, a weaker repulsion. Attraction wins, rule number 4. Let's see here. What happens if we reset, if we make 2 balloons, if we take the wall away? What happens if I take one balloon and put some negatives on there, set it way over there, and then this balloon here, I can actually cause the yellow balloon to be repelled from the green balloon. And if I move away, this thing starts coming back in, and I see that the likes are going to repel each other, and then the opposites will attract. Since the sweater is such a big positive source, it still has the ability to pull in this yellow balloon, even though the green balloon is sitting there as well. The last questions on 2.3 involve this rule number 4. It says, does the sign of the charge matter? We have this picture here that's really old for us at this point. This picture shows us that a positive will attract a neutral and a negative will attract a neutral. In either case, you have the opposite charges closer together than the like charges, and it's that simple, and so you always end up with rule number 4 happening with a charge and a neutral. And the last question is asking about the mass or the size of the objects involved. Basically, this question is referring to what happens if it is a really, really big charge and a small thing that's neutral. We get an attraction. What happens if it is reset our balloons here, put the wall back in. What happens if it's a really, really big object like the wall that's neutral and the balloon, which is certainly smaller than the wall, is charged? We still get rule number 4. So rule number 4, it doesn't matter which of our objects is the larger object, the charge or the neutral. It doesn't matter if it's a positive or a negative that you're dealing with. So with that, make sure you've reviewed anything you need to. You can go back and see the 2.2 presentation if you need to go through that again. This week we're going to end up, week 3, we're going to end up finishing everything in terms of our concepts up, and we will move forward into some of the math.